Okay, this is your video for 4.3, congruent triangles. We're going to prove that two triangles are congruent to one another. So first we need to know what congruent means. So we say figures are congruent if they are the same size and the same shape. Now you know that from middle school, from elementary. Same size, same shape means they're congruent. A more specific definition of that would be if their corresponding angles are congruent and their corresponding sides are congruent. Now, when I say corresponding, I don't mean corresponding like from chapter 3 corresponding. I mean that if they're in the same location, then they are corresponding. So, you know, corresponding from here means same location, top right, top right. Corresponding from here means the same thing. Now, the trick here, and you'll see this when we do some problems from this chapter, is that I can rotate this triangle and these can still be corresponding. They don't have to be, you know, bottom left angle. I could rotate this triangle around and now these two angles are still corresponding. They're still congruent. You have to look and see, are they labeled correctly? Not necessarily are they in the same spot. So that's a trick you'll see coming up, so don't fall for that. Okay, thus two polygons are congruent if and only if their corresponding sides and angles are congruent. And this is just the definition here written as a biconditional. We know it's a definition because I can read it forward and backward. So we're going to use definition of congruent polygons in a lot of our proofs today to prove why are these congruent. Well, definition of congruent polygons. Okay, so one thing, to name a polygon, we have to write the vertices, this is supposed to say consecutive, in consecutive order. And that just means next to each other. I can't jump around the figure. Now with a triangle, that doesn't matter. It's just either you go this way or you go this way. It doesn't matter. With higher order polygons, quadrilaterals, and above, all that means is I can call this, usually you start in the top left corner and you go around clockwise. So the traditional name for this would be RSTU. You can start anywhere you want, TURS. You can even go counterclockwise, TSRU. Those are all acceptable. What you can't do is jump across the figure. So I can't call this RTSU or USRT. I have to go in order, and that's the only thing you have to be careful about. Okay, when you write a statement such as triangle ABC is congruent to triangle DEF, you are stating which parts of the triangle are congruent. So that is helpful when somebody gives you a statement like this. Triangle PRQ is congruent to triangle STW. This tells you everything you need to know about this triangle without even a picture. It tells me the angles are easiest, so I'm going to start with that. Since P is first in this statement and S is first in this one, it means angle P is congruent to angle S and all the way around. Angle Q is congruent to angle T. And angle R is congruent to angle W because of the way that the congruent statement is written. Same thing with the sides here. Side PQ is congruent to side ST because first, second here, first, second here. QR is congruent to TW. And lastly, PR is congruent to SW. So if you can get a statement and know all these things about it, it's also important when you're given a figure and you have to write the statement to make sure you write it in the correct order. Okay, because if you were to scramble this up and let's say you were to swap S for T, you would be telling people that P is congruent to T when you really meant P is congruent to S. So writing these congruent statements is super important that you take the time and you write them in the right order. Because if you switch even two letters, the whole statement is incorrect. Okay, one little note that's going to be important because I've noticed this as I've taught this through the years, is that this is a congruent statement. So there will be problems where I'll say identify the parts and write a congruent statement, and I'll have 20 people say, what's a congruent statement? This is a congruent statement. It is a statement telling you these two things are congruent, hence the term congruent statement. So do not be one of those people, because I will say you should know what a congruent statement is, and I won't tell you. Okay, so here it is, congruent statement. Okay, let's turn the page here. Maybe. Alright, given that triangle ABC is congruent to triangle DBC, first find the value of x. So we can tell that here's x, and we can look at this in our figure here. Angle ACB on this side, ACB, would be congruent to DCB on this side. So you really have to look at the congruent statement and make sure which angles you're talking about are being congruent. You can't just assume and go from there, because maybe this was rotated or something. But since we know for sure that these two are, we can tell that this angle is a right angle. And since these are a linear pair, this angle has to be a right angle as well. They have to be congruent. Angle ACB has to be congruent to angle DCB from the congruent statement. So we can tell 2x minus 16 has to be equal to 90 degrees because it says so in the congruent statement. And then we can just solve from there. So 2x is equal to 106. Yep. And then divide by 2, so x is equal to 53. I could ask you to justify this along the way at any time, so we got to go back and know those theorems. This would actually be definition of perpendicular, and then it would be definition of a right angle there, so be careful with that. Okay, then the second part says find the measure of angle DBC. So DBC would be this one over here. Okay, so from the congruent statement, I don't know anything about this angle ABC over here, so that's not going to help me with DBC. What is that this angle 49.3 has to be congruent to this angle 49.3. So then I can use either triangle sum theorem or the corollary for the right angles, where the one that said the adjacent angles of a right triangle are also complementary. Either one of those you want to justify with is fine. It's easier to remember triangle sum. And then you can say, okay, 180, I've already used 90, I've already used 49.3. So let's see how much is left out of that. That would be 40.7 degrees. Very good. Okay, let's get into our proofs here. On this one, I forgot the picture fell off the page, so you're going to have to draw it in here. So let's see, this is Y, Z, W, X. Okay, not much room there. Alright, so given that YWX and YWZ are right angles, so as I read these, I'm going to go ahead and mark them. YW bisects angle XYZ. We know when things bisect, it means they're congruent halves. W is the midpoint of XZ. Same thing, we know with a midpoint that it's connected there. And XY is congruent to YZ. Okay, so lots of givens. So remember, you have two options. You can either use all the givens up front, or you can spread them out throughout the proof. So let's look and see what they did here. Considering I have givens all spread out here, I know they're going to spread them out. So what's important is to make sure you use the right given in the right place. So here we're going to use the first one first. So I've already used this one. Okay, the next thing says right angle congruence theorem, and that's from last chapter, and that said if you have two right angles, they have to be congruent because 90 has to equal 90. So we're going to come right here and say if these are both right angles, then they must both be congruent to one another. Now I want to clear something up from chapter 3 that I didn't bring up in every class. I saw a lot of things that said the measure of angle blah 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 is congruent to the measure of angle blah blah blah. Now remember, you're mixing up things here. Either the pictures can be congruent or the measures can be equal, but don't flip-flop in there, okay? Pictures are congruent, the measures are equal. I saw a lot of this being mixed up last chapter, and I don't want to see that too much anymore, okay? So pictures are congruent, measures are equal. All right, next it wants us to use another given, but I don't know which one, so I have to look down to step 4 to figure out which one. So step 4 says angle XYW is congruent to ZYW. So I want to use the one talking about this angle. So that would be this one. YW bisects angle XYZ. And we already have those marked as congruent because we saw that word bisect. And we know that if you do bisect, the definition of an angle bisector says that the two halves will be congruent. There you see that pattern again. Vocabulary word, definition right there. We have another given in step 5, so we need to look down to step 6 to see which one we should use. Definition of midpoint, so we should probably use the one that says midpoint. Now, these are going in order, the givens, but that doesn't always have to happen, so don't rely on that. Really go back and check which one they're supposed to be using. W is the midpoint of XZ. Well, what does that mean if W is in the middle? It means that XW is congruent to WZ. Okay, this one's a little different, but you're going to see this one a lot over the next 2 chapters. YW is congruent to YW. Anytime a line is shared by 2 different figures, this YW is used for the left side and the right side, then I need to tell people that's the same line that I'm sharing here. This is a property from chapter 2. Remember the whole 1, 2, 3 RST thing? This is where that comes from. This is one item. WY is the same thing. So that would be the reflexive property of congruence. Good. Okay, now we have the third angles theorem next, which that is something that we learned just last section, and it said if 2 angles from this side are congruent to 2 angles from this side, then the third angle has no choice but to be congruent. So angle X has to be congruent to angle Z. Good. Last one, XY is congruent to YZ. That is our last given statement. And I know my last statement overall has to be my proof. Okay. Now, why do I know that these 2 triangles are congruent? Well, I know because I've proved all 6 pieces, and you can count angles 1, 2, 3, side lengths. Where are my side lengths? 1, 2, 3. So I have all 3 angles and all 3 sides, so I can use definition of congruent triangles or definition of congruent polygons. Either one is acceptable to prove that these are. So when you have all 6, then you can say the whole shape is by definition of congruent triangles. And that's the main key point from today. Prove all 6, say they're congruent by definition of congruent triangles. Okay, last one here. The diagonal bars across a gate give it support. Since the angle measures and the lengths of the corresponding sides are the same, the triangles are congruent. This is kind of an overview of where we're going with this proof here. Okay, PR and QT bisect each other. Now, we talked about bisecting a lot in chapter 1. Now here, this phrase that they bisect each other means each of them is being cut in half. That does not mean all 4 of these are equally congruent. Maybe they are, maybe they aren't, I don't know, and I don't want to spend the time proving it, but I know that QS is congruent to ST because QT was bisected. I know that PS is congruent to SR because PR was bisected. So I'm going to label that like that, and I'll prove that in a second. PQS is congruent to RTS because that is given, and QP is congruent to RT. And I want to prove that this triangle QPS is congruent to this one TRS. So I don't even care about the top and the bottom triangle. I'm just going to use the left and the right one. Okay, looking down your proof, it's only 5 steps, and I can see I have 3 given, so I know that I'm not going to spread out my givens. I'm going to use them all at one time. So let's go ahead and copy those down there, and yes, you have to copy all of them down. No shortcuts. If they are nice enough to give you all this information without you having to go and find it, the least you can do is write it. My lettering got all off here, so I kind of changed it up to make it match. Okay, 2, we're using definition of a bisector, which means that we're going to use this given right here, PR and QT bisect each other. When I was going through labeling my diagram, I already said what that was going to mean. It's going to mean that QS is congruent to ST because that was bisected, And the other side, PS, is congruent to RS because that side was bisected. So right there in one step, I already got 2 out of my 3 sides. And I already had the third one because it was given to me. So first of all, I already have all 3 sides, so that's good. Okay, angle QSP right here is congruent to angle TSR right here. Okay, why are these congruent? Well, if you know this one from chapter 1, those are vertical angles, so we're going to use the vertical angles theorem to say that they're congruent. Okay, a little typo right here. This should say QPS. We already used QSP. We don't want to use it again. QPS is congruent to TRS. That one is from this chapter, the previous lesson. If 2 angles from this triangle are congruent to 2 angles from this triangle, then the third angles have no choice but to be congruent. That is the third angles theorem. And then lastly, of course, triangle QPS is congruent to triangle TRS by definition of congruent triangles. We got all 6 pieces, all 3 sides, all 3 angles, so then I can say the triangles are congruent by definition of congruent triangles. Okay, see you tomorrow.